In this discussion, we will introduce the intermediate value theorem. Here's a statement. You should know the statement. You should have it memorized. Here it is. If f is a continuous function on a closed interval from a to b, and the number m is some number in between the values of f of a and f of b, then the intermediate value theorem guarantees that there exists some number, we'll call it c, that's between a and b, that's maybe not between a and b, but on the interval a and b, such that f of c equals m. Okay, let's look at an illustration of that statement. Here we have a continuous function on the interval a to b. The function is continuous. It has no points of discontinuity on the interval a to b. Now you'll notice that f of a is this value up here. Right? There's f of a, the value of f of a right there. Here's f of b, it's this value down here. So, what the intermediate value theorem says that if there's some number that's in between those two values, some number, call it m, like that number. Notice that m is between f of a and f of b. Then the intermediate value theorem says that there's some number c, for sure, there's some number c on this interval such that the function evaluated at c equals m. And we can see that in this case it's definitely true. If you bring this m value over, it looks like it's about right there. There's our c right there, and there's our f of c right there, and f of c is equal to m. Now we're going to use this for different purposes, but here is one purpose that we will deal with in this discussion. We will look at the curve defined by this polynomial, and we want to show that the curve has a positive root. Well, if we can find a number, remember a root is some number k, such that if I plug k in for all the x's, I get 0. So if we can find two numbers, a and b, where one time we get a negative and the other time when we plug it in for all the x's we get a positive, then we know that there's some number in between a and b that is a root. Now notice what happens if we evaluate this curve at 0. You get a negative 6. So if we plug in 0, we get a negative 6. What happens if we plug in a larger number, like say, 4? Well, we have 4 to the 4th is 64. 4 to the 4th, I'm sorry, is 256. And 4 to the 3rd is 64, but 64 times 2 is 128. 4 squared is 16. We minus 5, that'll give us 80. And then 12 times 4 is 48, so that's minus 48. Well, notice that 256 plus 128 is larger than 80, 48, and 6. So if we put in y of 4, we get something that's positive. We get a number that is positive. That means that there's some number by the since this curve is continuous, remember polynomials are continuous, the intermediate value theorem applies. So by the intermediate value theorem, we know there exists some number k such that k is on the interval (0 to 4), and f of k is equal to 0. We know that because 0 is a number in between any positive and negative number. So this is like our m that's in between f of b and f of a. And k is on the interval from a to b, and it will make the function equal that m value. So that's an application of the intermediate value theorem.